In a previous video, I put together an automatic watch using components sourced on eBay. This watch was based on a Chinese clone of the ETA 2892 movement, and I was quite pleased with the results. The watch has been running very well since, but there was one thing that bugged me when I first put the watch together, and it still bugs me now: the dial. The dial was definitely, to my taste, a nice classic design, Roman numerals, with a gold-coloured inner ring. But one quite important thing was missing: some kind of personalization. I had initially been offered a collaboration with another party who knew all about pad printing, and I was very much interested to move forward with this. I personally know nothing about pad printing, but I thought it would be a fun project to make a pad printer on my 3D printing machine. For the quantity of dials I wished to make, it did not make financial sense to purchase a ready-made one. However, the collaboration just never happened, and so the idea was eventually shelved until further notice. The machine was half built, and I suppose I will finish it at some point, but in the meantime, I really did want to find a solution that I could occasionally use and would be good to present as a hobbyist project here on the Watch Repair channel. The reason why pad printing is pretty standard with the manufacturer of watch dials is that it provides consistent high-quality results over and over, and this makes it ideal with medium to large volume jobs. But for the hobbyist, it quickly becomes an expensive solution, what with the cost of the machine, the manufacture of the printing plates, the consumables, and the skill required to operate the whole system. It's really in the realm of mass production rather than one-off bespoke jobs. Of course, there are many ways to skin a cat, and with dial manufacture, you'll find manufacturers producing dials with many different methods and with many different skills to cover those methods. Dial enameling and hand engraving being just two very good examples of this. Now, I wanted a solution which could allow me to design a dial on my computer, print that design out, and then transfer that design onto my dial blank. But I also wanted that solution to be fairly non-obvious. I remember using water slide decal paper a while back on a project I was working on. It involved using an inkjet printer to print a design onto the special paper, which was then sealed with a lacquer. It was soaked in water, and the design was then able to be slid onto the substrate. Now, at the time, I thought that it would be a good solution for making custom watch dials, except for one thing. No matter how careful you were with cutting the film around your design, it was always obvious that the design was still attached to the film, and therefore the results did not really look that great. A bit of further research, and I believe I have now found a solution to this with these decal papers. These are very similar to those inkjet water slide decal papers, but they're designed for a laser printer instead. The advantage here is that laser toner is unaffected by water and has a tendency to adhere to the material that you're applying it to, and I will show you how. First of all, let's get a test piece of metal. Now, this is a piece of aluminium from my scrap drawer. I'm going to design a couple of dials in Adobe Illustrator. Now, according to the manufacturer's instructions, the design needs to be printed on the paper as a mirror image. So I'm just going to flip my design. Now I place the paper in the printer and I can print directly from Illustrator. Now, Illustrator is not the only software which can be used. There is a free Illustrator alternative called Inkscape, or any graphics software will do. Once the design is printed out, I can cut the design out into a manageable size, as the paper is A4 size to begin with. Now I have roughly prepared this scrap piece by giving it a little bit of a sand down, and I've cleaned it. And I can place one of the dial printouts in some water and leave it for a moment or two. The film actually becomes loose on the paper and can be slid out of place. Now I'm putting some water on the metal surface, and I can then place the film down on the metal and slide the paper completely away. I can then spend some time making sure that there's no excess water or air bubbles under the film. Now let's do that again with my second design. I place the design in the water for a few moments. The film becomes loosened from the paper and can be slid onto the substrate. Then I can spend some time removing excess water and air trapped under the film. All good so far. The next step is to place the whole piece in an oven for maybe 30 minutes at 100 degrees. This will bake the laser toner onto the piece, and it will hopefully stay in place. Now you may be wondering if the heat will damage the paint of the real dial that we're going to print. Well, we shall see in a moment, but let's complete the final step first. After the metal has cooled, I can now remove the film. Let's hope that the toner stays in place. I very slowly and carefully peel away the film, and I'm very pleased to see that the toner does indeed stay in place. Let's try again with the other design. Okay, I can see a problem here. There's a small portion which has not adhered properly to the metal, and it's still attached to the film. I will suspect one of two things. Either I did not clean the metal properly, or I didn't ensure that all the air trapped under the film was removed. Well, never mind. In theory, this actually works. The quality is not stunningly amazing. I mean, the print is not as sharp as a professionally manufactured dial, but it's certainly more than acceptable, and you really only notice the difference under magnification. I'm very pleased with that. So let's get the real dial printed. I'm a little bit worried, as I don't really know what the heat of the oven will do to the already painted dial, and I don't know if the toner will even adhere to it. But this is all an experiment, so let's just get on with it. So here's my dial. I want to print my custom logo. My surname is Lovick, so I think LVK may be a nice little take on that. I want to use lacquer once I've applied the design to the dial, and I thought it would be nice to have a slightly mottled effect to the finish, as this will help protect the toner as well. So I designed my dial in Illustrator, and I mirrored the design prior to printing it on the decal paper. Now I can go through the same steps again. all the while thinking I'm going to be stripping and painting and redoing this several times. So I place the design in the water and I slide it out onto the dial just like I did previously. The nice thing about this film is that it can be repositioned until I'm very happy with it. Now I can take special care to make sure that all the air and water trapped under the film is squeegeed out. And then I can bake the dial in my oven for about 20 minutes. I was nervous about leaving it longer. After the dial cooled, I lifted the film and gently started peeling it away. I did not truly expect the toner to be adhered to the dial paint, but it did, and it looked great. Now I used some clear lacquer spray with a large nozzle to create that mottled effect I wanted, and I let it dry, and I'm very pleased with the result. Now, some of you may remember I posted a video previously which demonstrated how I put back into service an Omega 2500 coaxial movement which was damaged by WD-40. The movement was very badly corroded and was actually replaced by the owner with a new one. The damaged movement was left in my scrap drawer as a result. In the video I made, I used that movement with a genuine Omega dial in order to construct a Frankenwatch using an aftermarket Omega Seamaster Professional case and bracelet. Now, I don't really wear a watch all the time, as I do have skin issues, but I do like to wear one of an evening occasionally. The problem with the Frankenwatch was that I never wore it. I was never excited to wear it as I knew it was a non-genuine case and bracelet. Now, I'm not a watch snob. I don't give a monkeys if people choose to wear counterfeit products. That's their choice. It's just never really made me feel good to wear mine. So I deconstructed that watch and I decided to repurpose the coaxial movement into a new Frankenwatch, the watch I previously put together using the Seagull 2892 movement. Now this is something I can wear and I can feel good about it at the same time. And so here we are, my Omega 2500 coaxial scrap movement working well and repurposed into an oyster style case with a bright yellow strap because, well, why not? With my own custom dial design and great possibilities for being creative in future projects. So what do you think about this method? Is it something that you will take a look into, or did you think it's, well, not worth the effort? Take a moment to comment your thoughts below. And if you like this and would like to see more of the same, please consider subscribing to this channel if you've not already done so. It is completely free, and if you hit the bell icon, then you'll be notified when I publish new content. But as always, thank you for watching, and thank you so much to all my patrons who really have made this content possible. So I'll see you in the next one.